October 1943. The outskirts of Salerno. The hillside shakes before the men hear anything. A German tank, edging forward through morning mist, forces its way past shattered farm buildings, grinding over fallen masonry with the slow certainty of something that cannot be halted. British infantry, pinned among terraced fields, have already seen their rifle fire glance harmlessly from its armour. Retreat is impossible. The slope behind them is bare and exposed. The tank halts, turret turning, engine idling like a held breath. The men know that once it opens fire, the position will collapse in seconds. One soldier crawls forward, dragging an awkward tube-shaped mechanism across wet soil, heavy, unfamiliar, and their last remaining hope of stopping the advance. In this video, we explore the unusual British invention that placed such desperate moments within reach of ordinary infantrymen. The opening years of the Second World War exposed a painful truth for British infantry. There was no simple, portable answer to the steadily improving armour of German tanks. Anti-tank rifles, once trusted to punch through early war plating, had been rendered obsolete almost overnight. Light artillery could do the job, but only if it was already in place, correctly sighted, and manned by a full crew. In the fluid fighting of 1942-43, where positions shifted by the hour and small detachments often found themselves isolated, none of this could be guaranteed. Front-line units repeatedly reported the same situation. When armour appeared unexpectedly, riflemen were forced to scatter or hope that supporting guns were close enough to intervene. Grenades and improvised charges demanded suicidal proximity. Even the boy's anti-tank rifle, carried with some optimism in 1940, became a burdensome reminder of how quickly battlefield technology had outpaced infantry equipment. It was heavy, conspicuous, and by mid-war almost entirely ineffective against the frontal armour of German tanks. The problem was not simply destructive power, it was the lack of a weapon that could be used immediately by ordinary soldiers, with no vehicle and minimal preparation. Compounding the difficulty was the growing importance of close-quarter fighting in built-up areas, orchards, vineyards, and rubble-strewn towns from North Africa to Italy. Tanks no longer appeared exclusively on open plains where field guns could be sighted in advance. Instead, they forced their way through streets or along narrow terraces where infantry might be the only force capable of responding in time. The army needed a device that could be carried into these confined environments, brought to bear at short notice, and, crucially, offer a realistic chance of stopping a tank before it overran a position. Existing solutions were either too heavy, too fragile, or too dependent on specialized ammunition. The challenge became apparent: to create an anti-tank weapon light enough for a single man to operate, yet powerful enough to defeat armor at the short ranges typical of ambushes. Moreover, it had to be mechanically simple, durable in field conditions, and safe to handle under stress. The absence of such a tool was not merely inconvenient, it had tactical consequences across entire theatres of war. By 1942, the question confronting British design authorities was no longer whether a new weapon was needed, but whether it could be built at all within the constraints of wartime manufacturing. And even if it could, there remained a more difficult problem: how to deliver a large explosive charge accurately without relying on heavy recoil systems or complex rocketry, technologies not yet ready for mass infantry use. This was the challenge passed quietly to a small circle of British engineers, and while their solution would soon reach the hands of soldiers on every major front, its earliest prototypes bore little resemblance to conventional weapons. Indeed, what they ultimately produced would redefine the very idea of how infantry might halt a tank. But to understand how such a strange creation emerged, we must look at the unusual engineering path that shaped it. The challenge of arming British infantry with a genuinely portable anti-tank weapon fell to a small network of organizations whose work rarely reached public attention. Among them were the engineers of the Ministry of Supply and the experimental teams at MD1, an establishment better known by its tongue-in-cheek nickname Winston Churchill's Toy Shop. These groups had already experimented with unconventional mechanisms for projecting explosive charges, including spigot mortars and demolition devices intended for commando use. It was from this background that the first ideas took shape. The central problem was both practical and philosophical. Conventional guns required a barrel strong enough to withstand high internal pressures and a recoil system to manage the force of firing. Producing such a weapon in a compact, soldier-carried format was nearly impossible with the materials and manufacturing capacity available in the early 1940s. Yet, abandoning the principle of a traditional gun opened the door to alternative methods of launching a heavy charge. One such method, the spigot system, had seen only limited application but offered intriguing advantages. Instead of the projectile being pushed down a barrel, it was placed over a steel rod. The explosive charge ignited around that rod, releasing the bomb without the need to contain high pressure within a tube. This approach significantly reduced weight and simplified production, but it created a new set of challenges. The launch force had to be strong enough to accelerate a large anti-tank bomb. The stabilization of the projectile needed to be reliable, and the mechanism had to be safe for repeated handling. Early prototypes of what would become the PIAT were crude, heavy springs, uncertain triggers, and bombs that occasionally behaved unpredictably. Field testers complained that cocking the device required considerable strength, and misfires could leave the operator in an exposed and dangerous position. Yet the promise was there. A weapon with no flash, minimal smoke, and a warhead powerful enough to threaten a tank at close range. The engineering teams refined the internal components step by step. They developed a large, compressed spring capable of storing the considerable energy required to drive the spigot forward. They designed a bomb fitted with a shaped charge warhead, which did not rely on velocity to penetrate armor, but instead focused explosive energy into a narrow jet. This principle, already understood theoretically, allowed a relatively slow-moving projectile to achieve armor penetration comparable to far heavier weapons. The challenge was ensuring the detonation occurred correctly at impact. Extensive testing followed, with many early bombs failing to detonate at the desired angle or producing inconsistent results on armor plate. Prototype after prototype passed between design offices, firing ranges, and operational advisors. Adjustments were made to the trigger linkage, the spigot's mass, the bomb's tail fins, and the layout of the firing tray. Manufacturing considerations were also pressing. Britain was already stretched by demands for aircraft, artillery, and ammunition. Any new weapon had to be built largely from stamped and welded components, requiring minimal machining. The spigot launcher lent itself to this, but the spring remained a bottleneck, requiring precise tempering and consistent performance despite harsh battlefield conditions. By 1942, a workable pattern had emerged, heavy, undeniably awkward, but effective in its essential purpose. It carried an internal spring that, once compressed by cocking the weapon, stored sufficient energy to hurl a shaped charge bomb towards a target without producing the characteristic backblast of rocket launchers. This lack of flash offered a tactical advantage, allowing the firer to remain concealed after the first shot, critical when confronting armor at short ranges measured in tens, not hundreds of yards. With a viable design on paper, the next step was to place the weapon into the hands of soldiers for practical assessment. Early reports were mixed. The weapon was undeniably powerful yet demanding in operation. Its spring took effort to compress, its weight felt excessive, and accuracy depended on calm handling in situations where calm was in short supply. But despite these drawbacks, the fundamental judgment was clear. It worked, and it could be manufactured in significant numbers. What remained was to formalize its role, give it structure, and introduce it to the army as a new tool for an old and dangerous task. The moment for that introduction soon arrived, revealing the strange device that would enter service under a name as unconventional as its design. As the prototype stabilized and field trials confirmed their essential reliability, the weapon was formally adopted as the Projector Infantry Anti-Tank, a title soon reduced by soldiers to its more familiar abbreviation, the PIAT. It represented a deliberate departure from conventional small arms, combining a spigot launcher, a substantial internal spring, and a shaped charge bomb into a single infantry-operated system. At first glance, it seemed almost improvised: a squat tube, a carrying grip, and a tray onto which the bomb was placed. Yet beneath its plain exterior lay a compact mechanism designed to deliver a powerful anti-armor charge without the flash or smoke associated with other launchers of the period. It allowed a single soldier without specialist equipment to launch a bomb capable of defeating the armor of most mid-war tanks at the short ranges typical of ambushes or defensive fighting. Its lack of backblast made it especially suited to built-up areas, where other launchers risked revealing the firer or injuring nearby troops. For infantry who had previously relied on rifles, grenades, or the uncertain arrival of supporting guns, the PIAT offered a degree of agency that had been missing since the early years of the war. But this new independence came with complexities. The mechanism demanded firm handling, the spring's energy had limitations, and the bomb itself required careful alignment to perform at its best. Soldiers quickly discovered that understanding the PIAT's behavior in detail was essential to using it effectively. To appreciate how this unusual device truly functioned and why it behaved as it did, we must now examine its engineering more closely. The PIAT's unconventional form was the result of strict wartime constraints. Britain needed a weapon capable of defeating armor at short range, yet simple enough to manufacture without diverting resources from artillery or aircraft. Traditional solutions, recoil-operated guns or rocket launchers, were either too heavy, too complex, or not yet mature. This forced engineers to consider methods outside normal small arms design. The key lay in reviving an older British concept, the spigot launcher. Instead of containing pressure within a barrel, the PIAT used a solid steel rod driven forward by a large internal spring. When released, the rod entered the hollow tail of the bomb and struck a percussion cap, igniting the propellant charge inside. This meant the weapon itself did not endure high internal pressure. The bomb carried its own miniature chamber. The design allowed for a far lighter tube than a conventional gun, though the spring required to propel the rod was formidable. Fully compressing it demanded considerable strength, and soldiers quickly learned that cocking the PIAT while lying prone was a challenge in its own right. Once cocked, the weapon was surprisingly quiet in operation. The absence of backblast, a major contrast with rocket launchers, meant it could be fired from windows, trenches, and enclosed rooms without risk to the operator. This was a significant tactical advantage. There was no bright flash to reveal the firer, no plume of dust, and no scorching gases to endanger those nearby. However, the energy stored in the spring produced a sharp recoil when firing. Ideally, this recoil recocked the weapon automatically, but only if the butt was held firmly against solid ground or the operator's shoulder. In loose soil or rubble, the recoil dissipated, leaving the spring only partially compressed and requiring a manual reset under pressure. The PIAT's real destructive force came from its shaped charge warhead. Engineers refined the bomb's internal cone and explosive fill to focus energy into a narrow jet able to penetrate armor far beyond what a low-velocity projectile would normally allow. Because penetration depended on the explosive effect rather than impact speed, the relatively gentle launch velocity posed no disadvantage. In practice, angle of impact was critical. Steep obliquity reduced effectiveness, and wartime reports note variable results depending on where the bomb struck. Even so, against the vertical armor of many mid-war tanks, the PIAT offered infantry a credible chance of success. Stabilization was achieved through fins at the tail of the bomb. They gave the projectile sufficient alignment during its short flight, though the slow speed meant operators needed to account for noticeable drop-over distance. Training emphasized calm sighting and an understanding of the weapon's arc. At typical engagement ranges, 20 to 50 yards, the PIAT was accurate enough for its purpose, though some soldiers described flights that curved unexpectedly when fins were bent or damaged. Materials reflected pragmatic British design. The main tube was welded steel, the spigot a machined rod, the spring a precisely tempered component that remained the most sensitive part of production. The trigger mechanism was deliberately uncomplicated, reducing the chances of fouling or breakage. Dirt could interfere with the sliding parts, but the weapon tolerated field conditions reasonably well when cleaned. Safety considerations centered on the bomb, which sat openly in the tray. Although the fuse was designed not to arm until the projectile had traveled a short distance, Operators treated the warhead with respect. Misfires occasionally left the bomb unexploded in the tray, requiring a controlled procedure taught during training. Despite nervous stories, documented accidents were relatively few, and most resulted from handling errors rather than inherent flaws. These engineering choices created a weapon with undeniable idiosyncrasies: heavy without a true barrel, reliant on a spring rather than powder, and capable of formidable armor penetration despite a modest range. Yet each characteristic arose from a rational attempt to give infantry a tool that required no specialized fuel, minimal machining, and as little battlefield signature as possible. Understanding the PIAT mechanically explains why it behaved the way soldiers described: abrupt in recoil, quiet in launch, powerful on impact, and occasionally stubborn when recocking. But the ultimate measure of the design lay not on the test range, but in the urgent, close-quarter encounters for which it had been created. To appreciate how those engineering decisions shaped real combat outcomes, we return now to the type of battlefield moment where the PIAT's particular qualities. The PIAT's entry into service brought mixed expectations. Some units welcomed any improvement over the boy's rifle. Others viewed the unfamiliar mechanism with caution. But early combat reports showed a clear pattern. When used at the close ranges for which it was designed, the PIAT offered infantry a realistic chance against armor that had previously dominated small engagements. Its shaped-charge warhead, independent of projectile speed, allowed even slow, arcing shots to threaten the side plates of mid-war tanks. Operational experience in North Africa and Italy revealed both strengths and limitations. In open terrain, the PIAT felt heavy and difficult to bring into position quickly, but in the close, irregular landscapes of villages, farmsteads, and terraced hillsides, its lack of backblast proved invaluable. Troops could fire from inside buildings, from cellar steps, or from rubble piles without exposing themselves to the dangers created by rockets. This advantage altered small unit tactics, giving rifle sections a means to challenge armor in places where field guns or anti-tank batteries could not deploy. The weapon's performance varied with training and terrain. When braced firmly and aimed calmly, it was capable of disabling or destroying tanks at short distances. Many successful shots targeted weaker side armor, suspension systems, or external fittings. Failures occurred too: bombs striking at shallow angles, shots disrupted by damaged fins, and difficulties recocking after a poorly supported first firing. Yet these limitations were understood and accepted. Soldiers learnt that deliberate preparation and knowledge of the weapon's arc were essential. Beyond its anti-tank role, the PIAT began to serve as a compact breaching tool. Its shaped charge could penetrate bunkers, earthworks, and fortified positions, making it valuable in assaults where engineers or explosives were not immediately available. Airborne units in particular made extensive use of it, appreciating that it contained no volatile propellant and could be carried safely in gliders. In the early hours after landing, often without heavy support, the PIAT offered one of the few means to deter a sudden armored counterattack. As training improved, confidence in the weapon grew. Some operators described it as demanding but dependable. Others noted that respect for its recoil and temperament was essential. Its quiet firing signature remained a distinctive tactical benefit, allowing an operator to remain concealed after releasing a shot, an unusual advantage in anti-tank warfare. Even so, the PIAT was never a simple weapon. Mastery required practice, and its practical range remained short. These were concessions accepted in exchange for portability and concealment. By 1944, newer technologies were emerging. Rocket launchers promised lighter weight and easier operation, though their backblast limited firing positions. The PIAT therefore continued alongside them rather than being replaced outright. It filled a niche that rockets could not, engaging armor or strongpoints from enclosed or partially concealed positions. Only after the war, with the refinement of improved propellants and more efficient shaped charge munitions, did the spigot concept finally give way to dedicated rocket systems. Yet the PIAT left important legacies. It helped refine Britain's understanding of shaped charge technology, influenced thinking on portable anti-armor weapons, and demonstrated the enduring importance of giving infantry an independent means of resisting tanks. Museums that display surviving examples often note their rugged, unsophisticated construction, a reminder of the pressures under which they were designed. For veterans who carried them, the PIAT symbolized an awkward but necessary answer to a critical tactical problem. Its reputation was neither uniformly heroic nor unfairly maligned. It reflected precisely what the weapon was, a solution shaped by limited resources, urgent need, and a willingness to adopt unconventional engineering. And in the close, anxious moments for which it was intended, the PIAT could change the balance of a fight in seconds. Now, the final question remains: how did such a moment unfold on that hillside above Salerno? The tank at Salerno shifts its weight, turret fixed now on the ridge. In the stillness that follows, the soldier feels the PIAT settle into his shoulder, its metal cold, its spring held in disciplined tension. The distance is short, uncomfortably so, and the weapon's familiar awkwardness presses against his stance. Yet for the first time that morning, he holds something capable of intervening. He draws a slow breath. The turret pauses. The bomb's fins tremble faintly in the air. When he presses the trigger, the PIAT recoils with its characteristic jolt, a muted thump rather than the violent report of a gun. There is no backblast to betray him, no flash to mark his position, only the steady arc of the bomb crossing the gap between survival and defeat. What follows is lost beneath dust and engine noise, but the moment itself endures. An infantryman, cornered by armoured certainty, using a device born of unconventional engineering to alter a few desperate seconds. The PIAT's legacy lies not merely in its records or penetration figures, but in these small junctures where determination and a curious spring-driven contrivance briefly held the line. And on that hillside above Salerno, as the dust slowly settles, the weapon has delivered the chance it was designed to give.